Welcome to third grade Unit 7, Measurement and Polygons. This unit is packed full of information that needs to be learned and memorized. Be ready with your note sheet and a notebook. Here we go. The first part we're going to talk about is all the different geometric terms that you need in this unit. The first one is a point. A point is just a dot located in any type of space. A lot of times we refer to it with a letter. So in this case, I'm going to put the letter A. So this would be point A. A line is something that goes on and on forever in both directions. So I always think it's kind of funny when teachers say line up. We really don't want a line because we don't want it to go on and on forever in both directions. We would have a point that it goes through from one end and another point through the other end. Now, if we were to name this on a piece of paper, I would name it A, B, and then I would put that symbol above it. So a line with the arrows showing that it is truly a line. A ray has a starting point, so we'll call that S, and it goes on and on through another point. So we'll just call that one T. When we're naming that one, we would start with our start point. We would then add our end point, and we would put the line with an arrow pointing the direction the ray is pointing. The last one is a line segment. A line segment has a starting point, so we'll call this one M, and it has an end point, N. So this is mostly what a teacher would probably want you to do when they say line up. They would want you to line segment up. Because we want a start point and an end point, we would put the letters there and we would just put a straight line without any arrows if we were to name it. The next two concepts you need to learn about is parallel lines and perpendicular lines. Parallel lines are lines that will never cross or touch if they continue on forever and ever. A good way to remember parallel is right within the name. It has two parallel lines. So the two L's in the middle of parallel create parallel lines. They will never cross or touch. The next one is perpendicular. Perpendicular are two lines that cross or could cross, but it has to be at 90 degrees. 90 degrees can be identified by a square, or it could even have the 90 degrees labeling. A rectangle, a square, all those shapes have perpendicular sides because the side and the bottom are 90 degrees from each other. If it is not 90 degrees, then it is not perpendicular. If the lines could cross or touch if we extended them, then it is not parallel. If the lines cross but it's not 90 degrees, we call that intercepting lines. It has to be 90 degrees in order to be perpendicular. All right, moving on to our next concept. Angles and angle types. The top ones are probably our most common, especially in third grade, but the bottom ones are going to be ones you need to know too. So be ready for these. The first one's acute angle. I always like to take out my cute little voice because when we hear the word cute, a lot of times it's something small and little and cute. This angle is going to be less than 90 degrees. It's such a cute little angle. The next one is our right angle. Right angle means that it is exactly 90 degrees. And again, we could call this perpendicular lines right here because they cross at 90 degrees. The next one is obtuse. I like to pull out my big tuba type voice and go obtuse because obtuse means it is big. It is bigger than 90 degrees, but it's less than 180 degrees. Because 180 degrees would be called a straight angle. Straight angles are 180 degrees. We have a starting point at maybe 0, and if we went all the way around, that creates half a circle, which would become 180. So anytime we see a straight line, it actually went 180 degrees. The next one is not as common, but it's something you should know. It's called a reflux angle. A reflux angle is bigger than 180 degrees, but it's less than 360 degrees. And then the last one is called a full rotation angle. That would create our circle. And that one's going to rotate around the whole circle at 360 degrees. Pause the video if you need to. Take some extra notes on these angle names and how much their measurements would be. Resume when you're ready. All right, the next part is talking about triangle names. I like to say that triangles have a first and a last name. Their first name is their angle name, and their last name is their side name. And so we're going to first look at their first name. We have a right-angled triangle if it has one angle that has a right degrees. So right here, this 90 degrees, that one's right. This one up here is acute. It's small and little, and this one here is acute. Now let's talk about angles and why that works. We would call this right because it has that 90-degree angle. If I were to add up all of my angle measurements in a triangle, it would equal 180 degrees. So if I take my 180 and I subtract out my 90-degree right angle, I am left with 90 degrees. That still needs to be shared between two other angles. So there's no way I can get anything bigger than two acute angles for the remaining angles when I have a right triangle. Same goes for an obtuse angle. Obtuse means it's larger than 90 degrees, so my other two remaining angles are going to be acute. Because it has anything other than acute, that's how it gets its name. The last one is acute angle. In this case, all three angles are acute. Now, what if you don't know, or it looks real close to being a type of angle, but you're not sure? What you can do is you can take a piece of paper, and on a piece of paper, it has a 90-degree angle from the bottom to the side or the top to a side. So you can use that piece of paper and stick it right on top of any of these triangle angles. If you line up one of the lines. If you see the other line, then you know it's obtuse, bigger than the 90 degrees. If the lines are right on your paper, then you know you have 90 degrees. And if one of the lines is on the bottom and the other line you cannot see, then you know it's an acute angle, smaller than 90 degrees. The next part we're going to talk about are the last names of a triangle. The last names are associated with their sides. The first one is called equilateral triangle. The first part of that word is pretty much the same as the word equal. So in this case, that triangle needs to have all sides that are equal. We also call that congruent. When all sides are the same, they are congruent. And we denote congruency with these little dashes. So because all sides are the same, we put these dash marks in. So if you see a triangle that has those 3 dashes, you know it's an equilateral triangle. The next one, I like to call it I saw some sleeves. It's really called isosceles. And if you say isosceles and I saw some sleeves really quickly together, They both sound kind of the same. And the reason I like to say I saw some sleeves is because hopefully you have 2 sleeves on your shirt and they're equal length. An isosceles triangle has 2 sides of equal length. And that's where we see those congruent lines where those side lengths are the same. The last type is called scalene. Scalene has no sides of equal length. All the sides are different measurements. So again, all triangles need to have a first name and a last name. And they can only have one angle name and they can only have one side name. Moving on to quadrilaterals. We're going to move this over a little bit if I can so that it's out of the way. Quadrilaterals, the word quad means 4-sided. So quad means 4, laterals means sided. So it's a 4-sided shape. Our quadrilaterals fall under different categories. We have the trapezoid family, the kite family, and the parallelogram family. Now, these are terms and definitions that you need to memorize. They are going to show up in 3rd grade math, 4th grade math, 5th grade math, and so on and so forth. The more you know these definitions, the more successful you're going to be as you go through all the grade level units. So let's start with trapezoid. Trapezoid, the definition says exactly one pair of parallel sides. My line got off a little there. Exactly one pair of parallel sides. We show parallel with arrows. The top and the bottom are parallel to each other. Notice that definition shows up again in isosceles trapezoid. In this case, it is again the top and the bottom that are parallel. Isosceles trapezoids adds to the definition. So we're going to change our color here. It adds that it has 2 congruent sides. Now remember, congruent means the same. And we show that with those little dashes. So that side there is congruent to this side over here. An isosceles trapezoid can be called a trapezoid because it fits the definition. A trapezoid cannot always be an isosceles trapezoid. It only can if it has the 2 congruent sides. Let's move on to our next one. This one is a kite. A kite says adjacent sides are congruent. Adjacent means that they're touching by a point. So this side right here is congruent to this side over here. So we're going to use 1 dash. This side right here is congruent to this side right here. So we're going to use the 2 dashes to show what matches up with which part. A kite can only be a kite and a quadrilateral. A kite does not fit the definition of a trapezoid. Let's move over to our last family. Our last family is the parallelogram family. We're going to switch colors yet again here. The parallelogram family says that 2 pairs of parallel sides. So the top and the bottom, and again, remember arrows are parallel, and the left and the right are parallel. We're going to add a second arrow to show what matches up. Now, if I look down my parallelogram family, I see that definition in rhombus. So it has the top and bottoms are parallel, the lefts and rights are parallel. I see that definition in rectangle. So the tops and bottoms are parallel. The lefts and rights are parallel. And I see that definition in square. Again, tops and bottoms are parallel. Lefts and rights are parallel. So a square can be called a parallelogram. A rectangle can be called a parallelogram. A rhombus can become a parallelogram. A parallelogram, though, can only be a parallelogram and a quadrilateral. Because if we look at a rhombus, and change our color again, a rhombus has all sides are congruent in part of its definition, which means all sides are equal in length. So we're going to put those slash marks to show. If I look down at square, it also has that definition. So a square can be called a rhombus and a parallelogram. A rhombus can be called a rhombus and a parallelogram, and all of them are quadrilaterals. A rhombus, however, cannot be called a square because in the definition of a square is the same definition as rectangle, which is 90-degree angles. So in the corners, we have 90 degrees in our shape. And we make those in as squares. Square also says 90-degree angles. So a square has those 90-degree angles in it. So a square can be a rectangle because you see the purple and the orange definition that the rectangle has. A square can be a rhombus because it has the purple and red definition. A rhombus cannot be a rectangle because it does not have the orange definition. A rectangle cannot be a rhombus because it doesn't have the red definition. A parallelogram cannot be a rectangle, rhombus, or square because it's missing the orange and the red definitions. So the items below can be called the things above it because it fits the definition. This is an area that's going to need some work and practice. This is a good one to create some flashcards so that you can practice the term with the definition. Moving on to types of polygons. Before we get going on types of polygons, let's take a look at a 3D shape over here. When we have the side or edge of a shape, that is exactly what it's called. It's the edge. The point on the shape where those edges come together is called a vertex or vertices when we have more than one. And then the two-dimensional side of a shape or top or bottom, left, right, is called a face. And we're able to count up how many edges, vertices, and faces we might have. Let's take a look at our types of polygons. The first one we have is a triangle. Triangles have 3 sides. The word tri means 3. Quadrilateral means 4. Penta means 5. Hexa means 6. Hepta, 7. Octa is 8. Non is 9. Deca is 10. Henna is 11. Do is 2. And then we have deca is 10. So that would be 12. Dodecagon is 12. Again, these are names that you need to have memorized with their side amounts. So you should know a 5-sided shape is a pentagon. You should know a 7-sided shape is a heptagon, and so on and so forth. Again, if you do not know these, don't have them memorized, making some flashcards that says maybe 12-sided on one side and on the other side says dodecagon, and you quiz yourself on them, that would be helpful. The metric system shows up in this unit also. If you can remember the phrase, King Henry died upon drinking chocolate milk, that can help you remember this chart. The king, the K, stands for kilo. Henry, we have hecto. Died is deca. Upon stands for our unit. Drinking, deci. Chocolate, centi. And milk, milli. Those are all the measurements used in the metric system. The metric system is used in all around the world except for the US. But we do use it in the US when we are talking about some types of measurements in math, and it is the universal measurement for science. So you'll start to see these a lot more in science class. Kilo is the biggest unit. We can compare that kind of to like our miles when we think it's a large measurement. Milli is super small. To give you a little bit of an idea, a millimeter is about the thickness of a dime. Not how wide it is, but if we put it up on end and you see how thick the coin is, that's about a millimeter. And so we have meters as a unit. They measure length. Liters measures liquid capacity. And grams, which measures mass. Those are the only 3 units we have in the metric system. If we have big, we add kilo into the front of it. If it's small, we add milli into the prefix of it. And then we can use hecto, deca, deci, centi, milli. Each of these units is 10 times bigger or smaller from the one next door. So this system works really well because it goes by powers of 10. Now in this unit, you're going to be asked what measurement would make the most sense. So an MM, because it has 2 letters, I know it's one of the prefix words, so it's milli. Milli would be really small. The Eiffel Tower is probably not it. The next one is meters. Meters is about from elbow to floor. And so we could potentially measure the Eiffel Tower from elbow to floor. And the last one is kilometers. This is, again, if we were going to be running a long race, we might measure it in kilometers. For the Eiffel Tower, the best measurement would be meters, because it's not quite going the distance that a kilometer would. So I think a kilometer is 1,000 times bigger than a meter. So that would be 1,000 elbow to floors. And the Eiffel Tower might be one of those, but it would be hard to get an accurate measurement if that's what we used. The next one is the length of a rattlesnake. Well, a rattlesnake isn't terribly big, so elbow to floor is probably not going to be the best measurement to get an accurate one. We'd probably measure this one in millimeters. The next measurement system is called the customary system. This is used in the United States for our measurement system. This one has a lot of information that needs to be memorized. If we look at length, we have 12 inches make a foot. 3 feet make a yard. 5,280 feet in a mile, and 1,760 yards in a mile. Some abbreviations: IN is inches, FT is feet, YD is yards, and MI is miles. If you don't know these conversions, you need to memorize them, because if I asked you a question of how many feet is in 5 yards, you should be able to say, well, there's 3 feet in 1 yard. So 3 times 5 would get me 15 feet in 5 yards. In the middle, you'll see Gallon Man. He helps us with our capacity. Capacity is our measurement. Now, Gallon Man, I like to say, is kind of built like our body. A gallon is the big main body part of it, and it's the largest measurement of liquid capacity. We have 4 bones that come off of our main body. We have 2 big arm bones on top and 2 big leg bones on bottom. Those are our quarts. So 4 quarts make a gallon. Off of each quart, we have 2 pints. And if you feel the bottom part of your arm or the bottom part of your leg, you actually have 2 bones in there. So 2 bones connected to the 1 bone of your arms and legs. So there are 2 pints to a quart, which makes 8 pints to a gallon. The last one is cups, and those are like your fingers minus your thumbs. And you have 4 of those, 2 per pint, but 4 fingers and toes, that would equal 16 cups to a gallon. So that can be some of those measurements. The other one you need to know is 128 fluid ounces equals 1 gallon. So again, these are ones that need some memorization. Making those flashcards, 1 cup equals blank ounces. And on the backside, you say 8 fluid ounces equals blank cups. And then you can flip them back and forth. The last customary system of measurement is weight. 1 pound equals 16 ounces. And there are 2,000 pounds to 1 ton. Notice ounces abbreviation is OZ. Pounds abbreviation is LB. Those are 2 that are just a little bit more unique than any of the other ones. This one right here, though, is definitely one you're going to want memorized. 1 pound equals 16 ounces. All right, now it's your turn to get started and try to give these a whirl. Pause the video and then resume when you're ready to check your answers. All right, welcome back. The first one, if Bailey needs 200 milliliters of lemonade to fill a small jar, how many milliliters of lemonade does he need to fill 6 jars? We would do 200 milliliters times 6, and we would find out that it is 1,200 milliliters of lemonade. The next one, Marley uses 40 liters of water for her garden. That is 12 more liters than Ryan. How many liters does Ryan use? We can use comparison bars. Marley has more, she goes on the top. Ryan has less, he goes on the bottom. And our change amount is 12. So we would end up doing 40 minus 12. That gets us Ryan's amount of 28. In number 3, Chase thinks this shape is a square. Amy thinks the shape is a rectangle. Who is correct? The biggest thing to know about this one is the shape they're really talking about is the outside of the sign. And really, they both are correct. The sign is a square, but a square can also be called a rectangle based on its definition. The next one down here, select all figures that have at least one set of parallel sides. So we're going to go and find any sides that will never cross or touch. So our pentagon up here, our parallelogram, and our trapezoid are all shapes that have parallel lines. If I were to extend the kite, they would eventually run into each other. And the triangle already has them all touching. The last example, draw a quadrilateral that is both a square and a rhombus. For this one, we do have to draw what a square would look like, because if we drew a rhombus, without those 90 degrees, it would not fit a square's definition. Is every rhombus also a square? No. A rhombus does not need to have 90-degree angles, but a square does. In this unit, try the skill plan for Grade 3, Unit 7 in IXL to give yourself some more practice. The Math Activity Center lesson checks is also a great place for some more resources. Rewatch the video as needed. Otherwise, good luck.